Good afternoon, everybody. It's the last talk before our plenaries, so we'll keep it fun and we will keep it existential. In the last 18 months, a lot of digital ink has been spilled over how AI and more specifically LLMs with their productivity gains will transform how we work. And let me tell you, that's probably the kindest way to put it because there's much more blunt predictions that have been thrown around. And my personal favorite is if you don't use these tools, you will be deprecated. The truthiness of these statements aside, it's personally generated a great deal of angst that I hear echoed in the interwebs. And this angst, for me, specifically takes the shape of the following problem. What does it mean to be the human in the loop? Wow, vocal shift. The dominating narrative proposes that craft-oriented software engineering is a thing of the past. Code is no longer written for humans. Code review is exposed as a sparring ground for stylistic nit and soapbox architecture. And sadly, I think this wave of change has most certainly killed the Vim versus Emacs debate. With AI agents at our disposal, the archetype for the successful engineer is someone who is results-oriented, able to experiment and verify the results, and curate high-quality context for LLMs to use during inference. But before we can talk about context, we need to talk about models. A model is a simple representation of something, and we all build models of the world based on sensory perception. We each hold a unique model of the world based on how we've experienced it. LLMs do the same, but their sensory perception is their training data. Humans, yes, I am also human, we use these models to understand and interact with our environment, and LLMs make predictions based on their training data. Both models are wrong, but luckily both are useful. Humans have more fluid and flexible models, and LLMs infer at a velocity that isn't limited by the output bus from our brains to something tangible. To the dismay of many junior engineers and many senior plus engineers, the answer to all questions is it depends. What does it depend on? Well, it depends on context. So how do we build context? Let's say you're starting a new job. You may first do structured learning, like orientation, onboarding guides, training videos, security compliance videos. Then you spend time at the company, you observe and talk to your coworkers, you ask questions, and perhaps the most accelerated way of developing context in our industry, you break and sometimes fix production. This informal context often supersedes the formal, curated context with information about how things work in practice. This is an inherent part of how we're built to work. We've primed instincts that drive us to explore our environment, find patterns, and emulate them instead of just processing the verbal information given to us. LLMs function rather similarly. They are trained on initial data sets in pre-training. They might be fine-tuned for specific use cases in post-training. And finally, they are given context for inference through the prompt and MCP-style inputs. This is a drastic oversimplification. I am not an LLM expert. This inference time context can be in the form of structured data produced by systems or documentation and data produced by humans and other AIs. The LLMs then use this information to perform inference. In other words, answer weird questions like, if you were an orange, what kind of star would you be? Because of their ability to mimic conversation, LLMs are very often presented through a chat or natural language interface. And I think that because of this, we anthropomorphize them, and as a result, we've adopted anti-patterns in how we interact with them. The first of these is talking to machines, and especially talking to machines like they're humans. It's very common to rationalize our relationship with LLMs like they are junior engineers. If we give them a well-defined task, then they can execute it on that task with a reasonable level of quality. Because of this, we speak to LLMs by providing declarative instructions. The LLM performs its inference, and based on the answer, we tweak the context with additional input until we are satisfied with the answer, or the underlying software systems reach their very real limit, the dreaded context window, or running out of tokens. Consider this my official motion to add the term ooting to our technical vernacular. For example, I asked Claude to make me a sandwich. Make me a peanut butter sandwich. It made quite a few mistakes, the most tolerable being its choice of creamy peanut butter over crunchy, and the most egregious being cutting it into squares instead of triangles. Who does that? It took quite a bit of iteration to get truly the correct sandwich. So what does this iteration cycle reveal? Aside from very poor taste in sandwiches, it stems from a misalignment of default assumptions. My idea of the perfect peanut butter and jelly sandwich is different from what Claude is trained to understand is a good peanut butter and jelly sandwich. In fact, when I questioned Claude about its assumptions, it revealed to me things that I hadn't even thought about, like the type of jelly, which, by the way, I'm an ingredient purist, so anything that's not grape is wrong, and the jelly to peanut butter ratio. As we've all been likely frustrated to learn, the more ambiguous we are with our prompts, the more we are implicitly relying on the default assumptions of the model. These biases and assumptions come from the model's training data, just like our own biases and assumptions come from our lived experience. And this frustration is not unique. A few years ago, Dove, yes, the soap company, created an inclusive prompting guide for generating images reflecting this exact problem. If you ask an image generator to generate a picture of a beautiful person, it's very possible that your idea of beautiful and the model's training data have very different ideas. The playbook focused on explicit description over declarative language to reduce the impact of bias and assumption in image generation. I highly recommend checking it out. It's actually pretty cool. So, why do we end up in this situation? The fundamental problem here is that natural language makes for a poor input into what is still a very literally minded machine. For all that LLMs can tell us what is likely, it does a poor job of discerning our true meaning. The meaning of what we say is informed by our unique model of the world, and an LLM will fill in gaps in its input with default assumptions that it's been trained on, not our assumptions or our experience. This brings me to our second anti-pattern. When we anthropomorphize models, we reflect ourselves in the model. We assume what we think the model knows, and that leads us to frustration. We ask the model to do something, and it doesn't do what we want it to do. Why did it not do what I told it to do? If you interrogate its first principles and assumptions, then we'd find that there's a disconnect between what we assumed and what it assumed. Some of you might be thinking, wait a minute, humans do that too, and you'd be absolutely right. We all enter conversations with our own mental models about all sorts of things from politeness to delivery to tone. Based on our experiences, we fill in fuzzy parts of our understanding, and it's not always correct. However, like I alluded to earlier, we have much more flexible and fluid models. We can dynamically and sometimes temporarily, sometimes permanently, correct our assumptions. Over the course of a conversation, we can detect differences between our model and our conversation partner's model. We then align and adjust the parts of our mental models needed at that moment to the person that we're speaking with. LLMs are not exactly designed to do this, but it can come quite naturally to humans. So since the model can't dynamically correct, we must adjust our inputs. Instead of talking to the machine, we must talk with the machine. I said it before, and I'll say it again, natural language is a poor input to machines. Language is fluid, it's ambiguous, it's dynamic. Every word you say carries nuance, and decoding that nuance requires understanding the speaker. Our new programming language is not declarative or natural, it's cooperative and explicit. We must work with an LLM to define and build our default assumptions, and we must structure our speech and conversation to support this goal. After my frustration with the sandwich, I took a different approach. This time, I asked Claude what its assumptions were. Then we went through them, correcting and discussing the variety of options for the different parts of the sandwich. I even learned something. Apparently, sourdough sandwich bread does exist. In the end, with principles aligned, it gave me the sandwich I wanted. By the way, this tactic works with humans too. When you find yourself in a conversation, talking past each other, taking a moment to align your assumptions goes a long way to helping your ideas converge. It's also important to understand in the context of this problem that humans have some really, really interesting consistency mechanisms built into them. It is very difficult for us to internalize principles and assumptions that deviate from our perceived identity. A previous team of mine operated with a very different set of first principles. The principles were soundly defined based on the trade-offs for the business, so there was a very logical justification for why we were doing them or why we adopted them. But they deviated so drastically from what I believe to be good engineering, or things that good engineers do, that it was difficult to internalize. Over time, it was harder and harder to make decisions aligned with the team's principles and still consider myself a good engineer, because each decision required re-reasoning through the principles that I could not internalize. In the end, the divergence of the decisions and my own model of how to do things was too much, and I sought out a different path. The great news is that LLMs don't have these sort of qualms about their self-identity, which makes for some very interesting opportunities to design and create systems under very different kinds of assumptions. It gives us a way to, if you will, test different assumptions. So, where does that leave us now? More than ever, we must interrogate and make explicit our most basic assumptions, even in natural language. It's not an easy thing to do. Over our lifetime and careers, we've internalized the fundamentals of how we do things to the point that we don't think about those basics by design. We project our own assumptions in a conversation to reduce the cognitive load of assessing our environment. We've heard over the last 3 days example after example after example about the importance of making these assumptions explicit. And if at this point you're maybe feeling frustrated with this conclusion, I totally understand. You might be wondering, do I really need to nitpick absolutely every assumption about every problem I present to an LLM? Why does it feel like I'm starting over every time I need to solve a different problem? This feels much harder than just doing it myself. What is the point? You're not alone here, and the tools that we are using are changing to solve these problems. We've seen recent evolutions in things like context compression and memory, so to speak, with some interfaces experimenting with the idea of dreaming, where your prompts act like additional training for the model in your conversations. If you can't tell by now, I'm a little bit of an LLM skeptic for a lot of reasons that we can talk about later, but I've accepted at the very least that they're here to stay. To manage my angst, I'm choosing to find and focus on the skills and opportunities that this age uncovers. Let's be explicit about categorizing machines as a separate audience when we're speaking in natural language. We already cater our speech to a variety of audiences as SREs in postmortems and in our daily life, and it's not a matter of using more precise language. If it were, then we'd fall back to using programming languages, but rather, let's use the structure of our conversation to surface and correct these default assumptions. Document these default assumptions in ways that help translate them from task to task. This goes beyond saying things like you are a Pythonic developer, and rather an imperative set of first principles to reason from and feed in as context, like use snake case for your variable names, read the poem. Write them down somewhere and tend to them like it's the garden that will save you from burnout in tech. And finally, let's recognize where our limitations are and use LLMs in ways that complement our own limitations. It's evident that they're faster at doing things once they know what to do, and I'm personally intrigued by this idea that we can simulate decision-making or development under different sets of first principles without sending someone to therapy. Circling back to my original question, I think I have my answer. I think being the human in the loop is about having the capability to recognize when your model of the world is wrong and be relentlessly open to tweaking and adjusting it. In a conversation, 2 people enter and 2 different people leave. As we stop and listen to each other, we shape and change each other as we subconsciously adjust our perspectives and assumptions. And I hope we can all keep interrogating and aligning our assumptions when we talk with machines and with each other. Thank you.